Welcome to the session on graphs and transformations. In this session, we will be looking at polynomial and reciprocal functions. The objectives for this session are to explore transformations of polynomial and reciprocal functions, f of x. The questions we will be considering are: how will a function be transformed when we add a positive constant to x, take a positive constant from x, multiply x by -1, add a positive constant to f of x, take a positive constant from f of x, and multiply f of x by -1. Let's summarize the effects of transformations on f of x first. So if we add a positive constant to x, then f of x shifts left. If we take a positive constant from x, then f of x shifts right. And if we multiply x by -1, f of x reflects in the y-axis. What happens when we add a positive constant to f of x? F of x shifts up. And if we take a positive constant from f of x shifts down. And how about if we multiply f of x by -1? F of x reflects in the x-axis. We will now investigate the effect on a polynomial function of adding or multiplying a value. Let's explore an example first. Consider the function f of x equals x squared. Let's find a few values of this function. So when x equals -2, f of x equals x squared, so -2 squared, which is 4, as shown. When x equals -1, f of x equals 1. When x equals 0, f of x equals 0. When x equals 1, f of x equals 1 also. And finally, when x equals 2, f of x equals 4. We can now plot this function using the table. -2, 4 is here, -1, 1 is here, 0, 0 is here, 1, 1 is here, and finally 2, 4 is here. We can join these points to sketch our function. Now let's add a positive value to x. Let's consider f of x plus 2. So when x is -2, f of x plus 2, replacing x by -2, gives us -2 plus 2 all squared, which is 0. When x is -1, f of x plus 2 is -1 plus 2 all squared, which is 1. When x is 0, f of x plus 2 is 2 squared, which is 4. When x is 1, f of x plus 2 is 1 plus 2 all squared, which is 9. And finally, when x is 2, f of x plus 2 is 2 plus 2 all squared, which is 4 squared, which comes to 16. So let's compare the old points and the new points. What happens from f of x to f of x plus 2? When x is minus 2, y goes from 4 to 0. When x is minus 1, y stays at 1. When x is 0, y goes from 0 to 4. When x is 1, y goes from 1 to 9. When x is 2, y goes from 4 to 16. The graph has therefore shifted left. This is a translation of the graph y equals f of x by the vector minus 2, 0. And what about f of x minus 2? When x is minus 2, f of x minus 2 is 16. For x is minus 1, f of x minus 2 is 9. For x is 0, f of x minus 2 is 4. When x is 1, f of x minus 2 is also 1. And finally, when x is 2, f of x minus 2 is 0. Again, let's consider the old and the new points in comparison to each other. So when x is minus 2, y goes from 4 to 16. When x is minus 1, y goes from 1 to 9. When x is 0, y goes from 0 to 4. When x is 1, y stays at 1. And finally, when x is 2, y goes from 4 to 0. The graph has shifted right. This is a translation of the graph y equals f of x by the vector 2, 0. Now let's consider the function f of x equals x cubed plus 2x squared. Let's multiply x by minus 1. So when x is minus 2, f of minus x is 16. When x is minus 1, f of minus x is 3. When x is 0, f of minus x is also 0. When x is 1, f of minus x is 1. When x is 2, f of minus x is 0. Again, let's plot these points. When x is minus 2, the y value goes from 0 to 16 when x is multiplied by minus 1. When x is minus 1, the y value goes from 1 to 3. When x is 0, y remains at 0. When x is 1, the y value goes from 3 to 1. And finally, when x is 2, the y value goes from 16 to 0. As you can see, the graph is reflected in the y-axis. Now let's see what happens when we add a positive value to the function. f of x plus 2 values have been given in the table. So when x is minus 2, y goes from 4 to 6. When x is minus 1, y goes from 1 to 3. When x is 0, y goes from 0 to 2. When x is 1, y goes from 1 to 3. When x is 2, y goes from 4 to 6. And as you can see, the graph has shifted upwards. This is a translation of the graph y equals f of x by 0, 2. Let's consider another example. What happens if we take a positive value from the function? This time, we have when x equals minus 2, y goes from 4 to 2. When x is minus 1, y goes from 1 to minus 1. When x is 0, y goes from 0 to minus 2. When x is 1, y goes from 1 to -1. And finally, when x is 2, y goes from 4 to 2. Clearly, the graph has shifted downwards. This is a translation of y equals f of x by the vector 0, -2. We will now consider another example. What happens when we multiply f of x by -1? All the values of f of x will become negative. So 0 remains at 0, 1 goes to -1, 0 stays at 0, 3 goes to -3, and 16 goes to -16. And now let's consider the comparative graphs. And as you can see, the graph has been reflected in the x-axis. We will now investigate the effect on a reciprocal function of adding a value. Let's explore an example. Consider the function f of x equals 1 over x minus 1 minus 2. We're going to add 3 to this function. So let's consider how we're going to sketch f of x. We are first going to consider the asymptotes. There is one asymptote at x equals 1, as the denominator is 0 at this point. We're now going to make x the subject of the equation to find the y asymptotes. So let's rearrange f of x to do so. Add 2 to both sides, multiply through by x minus 1, expand the brackets, and then make x the subject of the equation, as shown. So as you can see, there is another asymptote at y equals -2, as the denominator is 0 at this point. So there are asymptotes at x equals 1 and y equals -2. This is a sketch of the function y equals f of x. If we add 3, the graph has shifted upwards, and so have the asymptotes. Both have been translated by a vector 0, 3. This brings us to the end of this session. If you have understood its contents, you should be able to describe how a polynomial or reciprocal function will be transformed when we add a positive constant to x, or take a positive constant from x, or multiply x by -1, or add a positive constant to f of x, or take a positive constant from f of x, or multiply f of x by -1. Thank you very much for listening. If you would like to understand this topic in greater depth, do attempt the exercises related to it in your textbook.